Okay, the first thing that we're going to do is I'm going to go over just a little bit of the homework so that people know they're doing it right, or the people who didn't do it will have a chance to get it done tonight. Slope is the steepness of the line. Okay? In the first four graphs, they don't want you to actually write the numerical value of its slope. They're just wanting you to say what type of slope it is. What type of slope is this line? Positive. Turn around and pay attention, please. What type of slope is this one? Negative. What type of slope is this one? Right. And the last one? Correct. Undefined. Now, some people have trouble remembering these two. They get them mixed up sometimes. Think about it. If this line were a slide, would that be a very fun slide? No. Okay, it has zero steepness, so it has zero slope. Think about it. Steepness is a synonym for slope. That has zero steepness, right? So zero slope. Okay, in the bottom part, they did give you the equation for slope. However, anytime you're given a graph with 2 points, do you really need to use that equation? No. That's more needed when you're like just given 2 points without the graph. So, what all you had to do is you had to count the rise over run. To get from the left point to the right point, I have to rise 1, 2, 3, 4 units. So my rise is 4. And then I had to run 1, 2, 3, 4, 5, 6, 7, 8. So the run is positive 8, and then that reduces to positive 1/2. That's where you were supposed to do for the bottom 6. Okay, so if you didn't get that done, or if you did it wrong, you need to go back and look at that. Okay, now turn to page 13. Today we're starting average rate of change. A car owner recorded the number of gallons of gas remaining in the car's gas tank after driving a number of miles. Use the graph below to answer the following questions. A asks, what does the x-intercept represent on the graph? Well, what is the definition of an x-intercept? Right. And so the x-intercept for this particular graph is located where? 500, 0. Okay, it has an x value of 500, a y value of 0. What does 500 and 0 mean in words? That's not all though. 500 is the number of miles driven. What does the 0 represent? So tell me that in a sentence. You think that's possible? You're on the right track, Peyton. How about after 500 miles were driven?
He had 0 gallons.
Right. There are 0 gallons of gas left. Yeah. Okay, you have to be able to interpret the meaning of the intercepts. Shh. Okay, what does the y-intercept represent on the graph? Well, what is a y-intercept? No, what is a y-intercept? So in this particular graph, the y-intercept is 0, 20. In words, what do those numbers mean? What did you say, John Michael? Right, so couldn't we just kind of rephrase that as he started with 20 gallons of gas?
Exactly.
I'm videoing. point 212 represent on the graph, and is the point a solution of the graph? Well, let's go to 212. If I go right 200 and up to 12, does that point land on the line? Yes, so that means it is a solution. And what do those numbers represent? But tell me specifically with those numbers. Right, so after 200 miles driven, there are 12 gallons of gas left. What does the point 410 represent on the graph, and is the point a solution on the graph? Okay, well 410 would be right 400 up 10. Is that point a solution of the graph? No. So what does it represent? Nothing. Okay, now I want you to take a couple of minutes and try number 2, A through D. The graph below shows the relationship between the number of mid-sized cars in a car dealer's inventory and the number of days after the start of the sale. What does the x-intercept represent on the graph? Well, what is the x-intercept? 15, 0. Okay, remember, the x-intercept is a point. And so a point has an x value and a y value. What does that 15 and 0 mean in words? Very good. After 15 days of the sale, there were 0 cars remaining. Okay, what does the y-intercept represent on the graph? Well, what is the y-intercept? 0, 150. And what do those numbers represent? So maybe we should say the dealership had 150 cars before starting the sale. Okay, C. What does the point 10, 0, or 1050 represent on the graph, and is the point a solution on the graph?
Yes.
It is a solution because it's a point on that line, and what does that point represent in words? Right. There were 50 cars left after 10 days of sale. Okay, and then D, what does the point 5, 125 represent, and is it a point on, or is it a solution on the graph? No, it's not on there, because if you went 5, 125, it would be right there, which is not on the line, so it represents nothing. It's not part of the data. Okay, now turn to page 15. Genius. The graph shows the altitude of a plane. Find the plane's rate of change during the first hour. Now remember, rate of change is the same thing as slope. So anytime you're asked to find slope, don't you have to use the slope formula? And to use that formula, what do you have to have? 2 points. So, if we're trying to find the rate of change during the first hour, doesn't that mean from 0 minutes to 60 minutes? That would be the first hour. So what is your first point? 0, 0. Very good. And what is your second point? Right. Those are the 2 points you use because they represent the first hour. from 0 minutes at 0 feet to 60 minutes at 30,000 feet. To find the rate of change, you just do the slope. So y2 minus y1 over x2 minus x1. Doesn't that just become 30,000 over 60? And what does that reduce to? 500 over 1. What does that 500 word mean in words? Per minute. Good job. Alright, find the plane's rate of change during the second hour. So they're asking us to find rate of change again, so they're asking us to calculate the slope. To calculate slope, you have to have 2 points. What would those 2 points be if we're trying to find the rate of change during the second hour? Right. The first point would be when the first hour started at 60 minutes. And its altitude was 30,000 feet. And then the second hour would be 120 minutes. And the altitude was still 30,000 feet. So when you do the slope formula, y2 minus y1 is going to give you what? 0. And then x2 minus x1 is going to give you, well, what's 0 over 60? So we have 0 slope. Doesn't that make sense because it's a flat line between those two? It's constant. That means the plane has reached its highest point and it's not going any higher. This will remain constant until it's ready to land. An industrial safety study finds that there is a relationship between the number of industrial accidents and the number of hours of safety training for employees. This relationship is shown in the graph below. A says find the rate of change, and we know rate of change is the same thing as what? Slope. So that means we're going to have to use the slope formula, and to use the slope formula we have to have 2 points. Well, they gave us 2 points to use, 0 to 70 and 27, 0. Now, it doesn't matter which point you label what. This could be x1, y1, or this could be x1, y1. It doesn't matter as long as you plug it in correctly. So if I'm using this as my y2, it'll be 0 minus 270 over 27 minus 0. That becomes negative 270 over 27, which simplifies to negative 10. And isn't it technically over 1? Sometimes writing that over 1 will help you understand what it means. What does that negative 10 over 1 mean? Every hour of training, there are 10 less accidents. It should say R right there. Because it was a negative 10. But the accidents are going down at a rate of 10 accidents per hour of training. Okay, once you write that, go ahead and turn to page 16. Alright, yesterday we learned that we could calculate the average rate of change between 2 points by calculating the slope of the line which passes through those 2 points, and of course you use the slope formula. In real life, average rate of change tells how something changes over time. Example 1. The balance in a savings account over a period of 12 months is shown in the graph below. The average rate of change of the savings over the 12-month period can be found by calculating the slope between the point and representing the beginning balance in the account 0,300. What does 0,300 mean? Well, wouldn't that be 0 months, $300? Doesn't that mean when they open the account, they put in $300? And the point representing the balance in the account after 12 months would be 1,500. That means if they check on their balance at 12 months, they now have $1,500. So our job is to figure out how much money they're saving per month. Well, they kind of did it for you on this one. They did 1,500 minus 300 over 12 minus 0. That became 1,200 over 12, which means they're saving $100 per month. Now, they want you to use this graph to calculate the average rate of change of the savings account for the following, month 1 to month 4. Well, what would the ordered pair be for month 1? Guys? 1,400. If you go over to month 1 and then you go to the line, isn't that a y value of 400? What would the point be for month 4? 700. Okay, so when we calculate the slope of those 2 points, it'll be 700 minus 400, that's your y2 minus your y1, over 4 minus 1 for your x2 minus your x1, and that becomes what over what? Which reduces to over 1. Isn't that $100 per month? Okay, now let's do month 7 and month 8. You try it quickly. For month 7, what would the coordinate be? Okay, because at the end of 7 months, they had $1,000. And for month 8, what was the coordinate? Right. So now when we find the slope, it'll be 1,100 minus 1,000 over 8 minus 7, which becomes 100 over 1. Now, why am I getting the exact same slope for all of these? It's a linear function, and linear functions have a constant rate of change, right? Otherwise, it wouldn't be a straight line. Okay, flip to the next page. In a linear function, the average rate of change is always constant. Okay, I want you to take a few minutes and try example 3A through D. The distance a marathoner runs over time is represented by the graph below. What is the average rate of change, so the slope, in distance over the entire 6 hours of the race? Well, to find average rate of change, you have to do the slope formula. So you have to have 2 points. For the entire race, what would your first point be? 0, 0, before it started. And then the race ends at 6 hours, 26 miles. So wouldn't that just be 26 minus 0 over 6 minus 0? And that's a rate of what? So I changed it to a decimal so it would make more sense. 4.3 miles per hour. Now that's their average speed. Does that mean that for the entire race they're running that rate? No. You know what to do. Almost done. What is the average rate of change in the distance between the first hour and the second hour? Well, what is your coordinate for the first hour? And what's your coordinate for the second hour? Okay, so to find the average rate of change, you just calculate the slope. 9 minus 6 over 2 minus 1. So between the first and second hour, they were running at a rate of 3 miles per hour, because it would be 3 over 1. Now between the fourth and the 6th hour, what was the coordinate for the 4th hour? 4:16. And the 6th hour? So that would be 26 minus 16, which is, and then 6 minus 4, which is, and that reduces to 5. So they sped up a little at the end. C, is the rate of change in distance constant over the entire 6 hours? No. And they want you to explain. So you could say they slow down, speed up, and even stop sometimes. All right. You can also say the graph is not a straight line, so it doesn't have a constant rate of change. Okay, D, what's happening between hours 2 and 3? They're resting. They're not moving at all, because at 2 hours they were 9 miles away, and at 3 hours they were still 9 miles away. So they rested for a long time, which probably means they're going to lose this race. Okay, we are done. There's no homework.